Section 7.2 graphs the secant, cosecant, and cotangent. To graph the secant and cosecant functions, we're going to do these steps. We're going to graph the reciprocal function, either sine or cosine, make transformations to those functions. Then we're going to graph the vertical asymptotes, change all the maximum points to minimum points and all the minimum points to maximum points, and then graph their original equation. We'll talk about what those things mean. So for the first one, we're graphing the cosecant on the interval from negative pi over 2 to pi over 2. So since cosecant is a reciprocal function for sine, it's really equal to 1 over the sine of t. So that means that we're going to have vertical asymptotes wherever the sine of t is equal to 0, because our graph is undefined at these places, because remember, we cannot divide by 0. Now let's go ahead and start the graph. So when we're graphing this, we are going to first start off by graphing our graph for sine, since that's our parent function. So I know my sine graph has a period of 2 pi, so the key points are going to go by pi over 2. So the period for my cosecant is also going to be 2 pi. So remember, your key points, you take the period of the function and divide it into 4 equal parts. So 2 pi divided by 4 gives me pi over 2. So these are the intervals by which we're going to go by for our key points. So on my graph, I have to label everything. So pi over 2, this would be pi, 3 pi over 2, and this is going to be 2 pi. And then we want to graph all the way to negative 2 pi, so this is negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And then, of course, we always want to label our y-axis as well, so this is 4 and negative 4. So first start off by graphing your sine graph, and we all should hopefully know what the sine graph looks like now. It starts at 0. At pi over 2, it's 1. Then we have 0 at pi, negative 1, and then we got 0 again. So this is what my graph starts to look like. So that is my sine graph. Now for this, remember that the cosecant graph is 1 over sine. So wherever sine is 0, I know that I'm going to have a vertical asymptote at that place. So any place where you have sine of 0, now we're going to put in our vertical asymptotes. So sine is 0 at 0, so we have a vertical asymptote right here. Pi is also 0. 2 pi is 0. So then we got negative pi and negative 2 pi. Now that I have my asymptotes in my graph, the next thing I'm going to do is go ahead and to graph this. So for this graph, remember cosecant's 1 over the sine of t. So if you look at this part of the sine graph, notice that this part of the sine graph is getting closer and closer to 0. So when you have 1 over a small number, remember it's really equal to a big number. So that means if we have 1 over a small number equal to big number, so that means that this part of my graph is going to be coming up and going that way. If I do pi over 2, so the sine of pi over 2 is 1, so then the cosecant would be 1 over 1, which is still 1, so that's why this point stays on my graph. And then the next part down here, this part is again for sine coming closer and closer to 0, so 1 over a small number is going to be a very large number, so this part of my graph goes up this way. And we can also do that for each of these intervals that are in between my asymptotes. So I know that 1 over the sine of 3 pi over 2 would be 1 over negative 1, so negative 1, so that stays there for my minimum. And then notice that this part of my graph for my original parent graph for sine comes closer and closer to 0, and it's negative, so 1 over a very small negative number is going to be a very large negative number. So that means that my graph is going to start coming close to my asymptote going down this way, and this part would come down this way. So that's what it said before when you change the maximums to minimum points and vice versa. So this point at pi over 2 was a maximum, now it becomes a minimum point, and at 3 pi over 2 it was a minimum value, now it becomes a maximum. So then this point would be here, and my graph is going to go down, and then this point would go upwards. Now, of course, we would then want to take our eraser and erase the parts that we have for that sine graph that we first drew, because that's not really part of our secant graph. So I'm going to do that with my eraser. So after we erase that sine graph out of there, this is what our parent graph for the cosecant looks like. Now for this, notice that our graph still repeats from 0 to 2 pi, because we have a part of a graph that goes up and then it goes down and then it starts to repeat. So that's why our period was still 2 pi and the key points were pi over 2. Now for this though, the range is different and also the domain is not the same. So the domain is all real numbers, except everywhere we have asymptotes. So notice the asymptotes are occurring every single pi. So what's the first place that it occurs at? 0. So it would be 0 plus pi k, or you can just write pi k, or actually let's use n because that's what we've been using. So pi n, where n is equal to an integer. So that would be the domain. So, or if you want to write negative infinity to infinity, t not equal to pi n, that would be fine too. Now for the range, notice that the range values start from, they're going from here to negative infinity, and then we have values here that go up to positive infinity. We just don't have the values in between. So then my range is going to be negative infinity to negative 1 bracket union bracket 1 to infinity. And another thing to talk about this, because our sine graph is an odd function, remember odd functions, if you have the point x, y in your graph, so pi over 2, we have 1, you should have negative pi over 2, negative 1, which we do have on our graph. So that means that this is an odd function. And remember that odd functions have origin symmetry. And that means that the cosecant of negative t would be equal to the negative cosecant, of t. And that would be for this. And again, notice that one cycle for my graph is from 0 to 2 pi, and then it's going to start repeating. So this is what my parent graph for cosecant looks like. So you should know what this general shape looks like. So now we're going to go ahead and graph the secant of t on the interval from negative 2 pi to 2 pi. So the secant of t is a reciprocal function for the 1 over cosine of t, so for cosine. So that means it's going to have vertical asymptotes wherever cosine t is equal to 0, because our graph is undefined when we have 0 in our denominator. So for this, I'm going to graph with the same key points that I used for my last graph. So I know the period, which I'm going to tell you is still going to end up being 2 pi. So that's why we know our key points are going by pi over 2. So this would be pi over 2, pi, 3 pi over 2, 2 pi, and then negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And then this would be 4 and negative 4. Now for this, we're going to first go ahead and graph our cosine graph. Remember, cosine starts up at 1, so the cosine of 0 is 1, the cosine of pi over 2 is 0, pi would be negative 1, 3 pi over 2 is 0, and 2 pi is 1. So this gives us our cosine shape. And then, of course, we're going to go backwards. Now from this, everywhere cosine is 0, that is where we're going to have asymptotes on our graph. So now if I look here, I have 0 at pi over 2, and at 3 pi over 2, and at negative pi over 2, and negative 3 pi over 2. Now for this, just like for the sine graph, everywhere that we have our maximum minimums. So at 1, that's a maximum. That's going to become the minimum of our graph because we would have the cosine of 0 is 1. So 1 over 1 for secant would still be 1. And for pi, 1 over negative 1 still is negative 1 right here. So that's going to be the same. So those points stay. And then remember, as your cosine graph gets closer to 0, that means 1 over a very small number gets very large. So our graph's going this way. And then this graph goes down. And this part goes up. And of course, we would have this part being up too. I just didn't graph it. We only want to graph from negative 2 pi to 2 pi, so that's why I'm not graphing that part right there. And then this part would go down. And this part goes up. So then the next thing I'm going to do is I'm going to erase that blue graph where I drew cosine because that's not really a part of my secant graph. So I'm going to pause it and do that while you guys do that. So now that we've erased our cosine graph, this is what the parent graph for secant looks like. And notice that for this graph, when one cycle before we repeat ourselves is the length of the horizontal distance length of 0 to to 2 pi is what it is. So in this case, we start at negative pi over 2 and it goes to 3 pi over 2, kind of complete one cycle. And then for this, notice that if we were to fold our graph in half on the y-axis, it would match up. So that means that this is an even function. And remember, even functions, like we just said, have y-axis symmetry. So that means that the secant of negative t is equal to the secant of t. The domain for this function is all real numbers except for, so I'm going to write this the other way, so negative infinity to infinity, except for t values cannot be equal to everywhere we have asymptotes. So everywhere we have asymptotes starts at pi over 2, then we have 3 pi over 2. Notice the distance in between everyone is pi, so we start with the first one, which is pi over 2, plus pi times n, where n is equal to an integer. So that gives me my domain, or remember, you can just use a real number symbol if you want. The range goes from negative infinity and then it stops, so right here at negative 1, and then from 1 to infinity. So make sure you know all these. And the next graph that we're going to do is going to be the tangent graph. I should say the cotangent graph. So for the cotangent graph, remember it's reciprocal of tangent, so 1 over the tangent is the same thing as cotangent. And remember that that can also be written as cosine over sine, just another way. And because of this, we have vertical asymptotes anywhere the tangent is equal to 0 or anywhere the sine of t is equal to 0. Because our graph is undefined when we're dividing by 0. So the first thing we're going to do is graph the tangent graph. Then you would make transformations to that, then graph the vertical asymptotes, and then we're going to change it into cotangent. So starting off with the tangent graph, remember that the tangent graph period is pi, so our key points are by pi over 4, so that's what we're going to count by. So this would be pi over 4, so that's 1 pi over 4, and then pi over 2, because that's 2 pi over 4. Then we have 3 pi over 4. And then we have 4 pi over 4, 5 pi over 4, and then 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and then 8 pi over 4, which is 2 pi, and then I'm going to do that in the negative direction. Now that I have that, I'm going to go ahead and graph my tangent function, but I'm not going to put my asymptotes in because it gets kind of messy when you do all of that. So remember, for tangent, we have asymptotes at pi over 2 negative, positive pi over 2, 3 pi over 2. So right here, here, and here would be my asymptotes. And then remember that the tangent graph starts here at 0, 1, and then we have negative 1. So our graph goes up like this and then follows along our asymptotes. And I'm going to keep on doing that. So at pi, we have 0, 1, -1, and then we follow along our asymptotes. And again, I just didn't draw the asymptotes in because I don't want our graph to get too messy with everything on it. So I don't need that point there because we're only graphing from -2 pi to 2 pi. So this is our tangent graph without our asymptotes drawn in. Now for this, remember we said wherever the tangent is 0, that's going to become your asymptotes for your cotangent graph. So now I see where my tangent graph is 0 for each one, so I'm going to draw in my asymptotes. And that's why I didn't put the asymptotes for the tangent graph in, because like I said, it gets kind of messy. So now that I have my asymptotes drawn in, now I'm going to think about the rest of the graph. So for the rest of the graph, remember everywhere I have these 0 or the asymptotes, those are where the sine is also equal to 0. So now to get the rest, if I think about the tangent graph, I can use that, or I can think about cosine over sine. So I know that the tangent of pi over 4 is 1. So if I do 1 over 1 for the cotangent, it's still a value of 1. So these values that I have here for 1 and -1 are going to stay 1 and -1. So these values right here stay. So I'm just going to put dots there. And then since it's cosine over sine, I know wherever cosine is 0, then wherever cosine is 0, that means that tangent or cotangent is going to be 0 at that value. So remember where our asymptotes used to be for tangent, that's where we're going to have 0 on our graph. So we're going to have 0 here, pi over 2, -3 pi over 2, positive pi over 2, positive 3 pi over 2, and then the rest of your graph goes up this way. So it kind of switches from the tangent and moves down. So this would go up this way and then down. And this is going to go up this way and down. So this graph in green and blue would be my cotangent graph. So now the next step I'm going to do is I'm going to erase the red that I have up there, or you guys should erase your tangent graph, and that's going to be my cotangent graph. So now that I erased that part, now I have my cotangent graph. So if we look at our cotangent graph, notice that one cycle repeats itself from 0 to pi, and then it completes again, so that the domain, or so I'm sorry, I should say the period is for this going to be pi, just like the tangent's pi. We know that cotangent is pi. So just like sine and cosine are 2 pi, we know that cosecant and secant are 2 pi. So the key points for this go by pi over 4. The domain is all real numbers except for our vertical asymptotes, so where tangent is 0 or sine of t is equal to 0. So if I want to write -infinity to infinity, except for t values cannot be equal to, where's the first one that I get here at 0 and every single pi, so 0 plus pi n, where n is an integer. I don't need to write it like that, so not equal to pi n, where n is equal to an integer. The range for my graph, if you look, goes from -infinity to infinity. So again, the first cycle for cotangent occurs from 0 to pi. So it's a little bit different than the tangent. So this is going to be, again, from 0 to pi. Where if we go back to the other ones, the first cycle for our first graph that we had, which was cosecant, so the first cycle is from 0 to 2 pi, not including 0 and 2 pi. And for my cosine, or for secant graph, my first cycle is going to also be from 0 to 2 pi, so it's like we cut our graph in half. We're going to use from 0 to 2 pi. You could use -pi/2 to 3 pi/2, but we're going to do the half. Oops. So in this next part, we're going to graph y equals 2 times the secant of t minus 3. So we're going to do this a couple of ways. So when I'm graphing these, the first thing I always do is think about what is the reciprocal function. So for this, I know that the reciprocal function of secant is cosine. So because of that, that means I'm going to graph instead first y equals 2 times the cosine of t minus 3. And the reason I'm going to graph this is because it helps me figure out where my graph is going to be for the secant. Now for this graph, when I'm doing this, I know that the period for cosine is equal to 2 pi, and the key points then go by pi over 2, because you divide the period by 4 into 4 equal parts. The amplitude is equal to 2, which means we have a vertical stretch by 2, and then we're shifting our graph down 3 because of that minus 3. So down 3. So if you want, if it helps you to make a table and graph, that's fine. Or if you can just graph it, that's fine too. So I'll make a table and I'll graph it. So for this one, we have t values and then 2 times the cosine of t minus 3. So when I do my t values, I start with 0, pi over 2, pi, 3 pi over 2, 2 pi. So the cosine of 0 is 1, 1 times 2 is 2, and 2 minus 3 gives me negative 1. The cosine of pi over 2 is 0, and 0 times 2 is 0, minus 3 is negative 3. When I plug pi in for t, I get the cosine of pi is negative 1 times 2 is negative 2, minus 3 gives me negative 5. If I plug in 3 pi over 2 for t, I'm going to end up with negative 3. And when I plug in 2 pi, I get negative 1. So those are the values on my graph. So if I go up here, I can graph those. So the first thing I want to do is always plot my x-axis down to pi over 2, pi, 3 pi over 2, 2 pi. And so we're going to do this as negative 7. Now for this, I know that my vertical shift moved down 3, so I'm going to go ahead and put that in at negative 3. So 1, 2, 3. So this is where my x-axis is moved to. Now for this, I know that that's where it's moved from, and my graph has an amplitude now of 2, so instead of being at 1, we shifted up. So I know that the next part of my graph would be here, here, and I can just count 2 away from my new x-axis to get this. So my graph looks something like this. So that is y equals 2 times the cosine of t minus 3. And again, the reason I did that is because this is going to help me graph my secant graph. So for this, I'm going to put my asymptotes in wherever my graph is going to be hitting my new x-axis that shifted down. So where does it first hit? It hits here at pi over 2, at 3 pi over 2, negative pi over 2, and negative 3 pi over 2. And remember, your maximums become minimums and your minimums become maximums. So then the rest of my graph starts here, and then it's going to go down this way. And then this part would go up. These parts go up. And then this part would go down. So that's why it's important to know how to graph your parent graphs for sine and cosine, because it helps you get that part. And then, of course, this part in black is not really on my graph. Whoops. So I'm going to have to get rid of that part by using your eraser to erase it, or whatever you need to do. So I'm going to pause it and do. So I have erased that part of my graph, and now I have my graph that I was supposed to do, which is 2 times the secant of t minus 3. Now, for this graph, if I wanted to, I could come up with the domain and range. So let's talk about that. So my range has changed. My domain, we look at our asymptotes to help us with that. So the domain for this graph, my first asymptote is still at pi over 2. So my domain is going to be all real numbers not equal to pi over 2 plus pi times n, where n is equal to an integer. Now my range has changed because notice I'm going from down here, negative infinity, and I'm stopping right here at -5. And then we have -1, and we're going to infinity. So that means my range is going to be from negative infinity to -5, and then from -1 to infinity. So all in between here, those numbers, we don't have anything on our graph. So what I want you guys to do then is to try to graph number 2 right here on your own. So again, use the reciprocal function to help you and then erase it, and then see if you can write down the domain and range, and we'll look at that in class. Now, one last thing that I want to do is, since we haven't talked about it yet, is talk a little bit about calculator stuff. I want you guys to be able to graph these by hand, but just for the sake of being able to check your answers while you're at home, you can, graph these on your calculator. So if I go to my graphing calculator, and let's say I want to graph the sine of x, whenever you're graphing these, you always want to make sure you're in radian mode. So I'm going to go to my mode, and I'm already in radian, so I'm good. So if I go back to my y equals, I have my graph in. Now, if you go to zoom, the cool thing about zoom is you'll notice that number 7 says z trig. That means zoom trig. So it gives you nice values to use when you're graphing. And so this would be my parent graph for sine. And if you go to your window now, look at your values. So zoom trig, if you notice you have -6.15, which is very close to -2 pi. That's why. So I like to put in the actual value. So I'm going to put in -2 pi. And then here I'm going to put in 2 pi, because I'm going to graph it from -2 pi to 2 pi. And then if you look at this value, 1.57, that's really your key points on your graph. So remember, our key points for sine is pi over 2, so secant pi divided by 2. And if you hit enter, notice that's where we got that number from. And then we're looking at y values from -4 to 4 with a scale of 1. So that's why we have all our key points on our graph, which is kind of nice. If I were to leave it as zoom 6, just to show you, zoom 6 does not give you quite as nice of a graph. It doesn't give you those key points. We have all those points in between. And when you look at your window, notice it's not giving you windows by going by -2 pi to 2 pi. So that's why I usually like to hit zoom 7, and then I'll change the window from there. So if I also go to my graph, if I want to do my reciprocal functions, I can do 1 divided by the sine of x. So if I do 1 divided by the sine of x, remember that this means that we're going to be graphing the cosecant function. So if I hit graph now, or zoom 7 first, and graph, this is what my graph looks like. Now notice it doesn't put those asymptotes in for me into the cosecant graph, but for this, you can, put them in yourself. So remember, they start at 0, so the asymptotes would really be here, there, and there. So make sure you would put those in. So this is an easy way to check to make sure you're graphing these correctly, and then you could go to your table and check out the table values, and you can look at better values than you have right here by going to second window, and notice it says table start. So if I start at 0, and then this is the table that you want to change by. So let's say I want to go by my key points, which are pi divided by 2. So if I want to go by my key points and go to my graph, notice that gives you error at 0 because we have asymptotes there. We have a value of 1, error. So then if I go back to just my sine graph, just to look at this a little bit better. So if I go to second graph with those key points, notice it gives me those key values that I have. And again, I did that by just changing my table start by using my key points and starting at 0. And of course, I can do this for tangent and cotangent. So I just want to show you if I graph cotangent, I'm going to clear the screen here. So if I do 1 divided by the tangent of x and graph, notice that this gives us our graph here. And remember, for this, I'm going to go to my window and change it from, I'm going to go from 0 to 2 pi. And remember, our key points aren't going by pi over 2 anymore. They're actually going by pi divided by 4. So if I hit graph, I get all those values in. So that's from 0 to 2 pi. And don't forget, we have those asymptotes. So there's one at 0 here, and there's an asymptote right there that I would draw in. And then, of course, one over here as well. So easy way to check your homework as you're graphing them. And again, make sure for class that you also graph number 2, and then we'll look at it together.